3 seconds to where it was before.
Okay.
It's a very, very simple test, and we can do that together right now.
All right. The other thing we're doing is we're actually heating the oxygen sensor tip to 600 degrees Fahrenheit, which has to be done for a bench test or an on-the-car test, either way. Before we light the torch, I'm just going to put my safety glasses on, and we'll get this lit. I'll point this away from us. Okay, we have that lit now.
I'm turning the voltmeter on to the lowest voltage scale, the 2-volt scale, because these oxygen sensors only produce about 1 volt or so.
Sure.
So you need to be on your low scale. Then we're going to connect the red lead of the voltmeter to the wire end, in this case, or the terminal that you would have. And you must remember to use the black wire. Sometimes an oxygen sensor has more than 1 wire. Some have little heaters in. So always remember to use the solid black wire.
Good point.
And then connect your ground lead of the voltmeter to the shell of the oxygen sensor. You can just hold it like this.
Okay.
Now I'll insert it in the flame, and we'll see if this oxygen sensor can produce 9/10 of a volt within 1 minute.
Okay. Well, it's already starting to produce a voltage. 5, 6, 7, 8, 9/10 of a volt already.
Okay, so far
1
so
volt.
good.
Yep.
So I'm going to pull it out of the flame, and we'll see if it drops.
1001, 1002, 1003. It's right back down to 0.008 and dropping.
Okay, great. So I think that this one here, although it still functions, has just been in there quite a long time and was replaced just because of maintenance. So this is a good oxygen sensor, and that's how you can tell if they're good or bad right on the bench.
Okay.
Now, one thing I'll do, though, is put this down into an ashtray or someplace where it can cool off, because they're quite hot for a while.
All right. Now, there's an on-the-vehicle test that can be performed also. And why don't we head out in the garage and show them that one?
Okay.
Now, along with the simple bench test, you can also test your O2 sensor right on the vehicle. And we're going to demonstrate that right now, right, Jim?
That's right. Now, basically what we're going to need, Scott, is a voltmeter set on the 2-volt scale because the O2 sensor produces a very small voltage. And I'm going to connect the voltmeter first to a good ground. The negative lead gets connected to a good engine ground.
Sure.
And then I'm going to reach over and unplug the O2 sensor lead and connect the positive lead of the voltmeter to the O2 sensor's lead. Now we'll be able to measure the voltage while it's right in the engine. Now we're going to have to run the vehicle and change the air-fuel mixture ratio. The simple way to do that would just be to create a vacuum leak.
Sure.
And there's a vacuum port right here on the top of this engine with a little rubber cap on. So if you have one of these on your car, there's a little clip that you can use a pair of pliers to remove and get that out of the way, and then simply pull the little boot off. And that will create the vacuum leak that you need to change the mixture. So I'll start the car, and we'll do that.
All right. Now, we've previously run this engine for a little bit of time to warm it up, too. Okay. You might need to run the engine for a little additional time, and our meter's starting to come up now. So I think our O2 sensor is warm enough. And it does have to be at least 600 degrees Fahrenheit for this test to work.
Now I'm going to go ahead and open up the vacuum port, and we should watch the numbers drop as we wean the mixture.
Yep, going way down. Put your finger over it, plug the vacuum leak, numbers go back up. Way down, and back up.
Now, as you can see, the engine almost stalled on this test, and on some vehicles it actually would stall. So on those vehicles, we'll have to do something called a propane enrichment test.
Sure.
And so I'm going to take this valve, which we have screwed to a propane bottle. It's a regular propane bottle with a special valve on it for doing this test, and connect it to the vacuum port.
Okay, now we have a slight vacuum leak introduced, so we're seeing a real low voltage on the voltmeter, which is a signal of a lean mixture. Now, if we open the propane bottle up, our reading should go up. There it goes, way up.
And as I shut it off, it goes back down.
Way back down.
But this gives us the opportunity then to test an O2 sensor on the vehicle with either a vacuum leak or a propane enrichment test.
Let's review the test procedure for an oxygen sensor that has been removed from the vehicle. The first step is to remove and inspect the oxygen sensor. Set the digital voltmeter, or DVOM, to the 2-volt scale. Connect the DVOM red lead to the black wire of the O2 sensor and the black DVOM lead to the oxygen sensor outer shell. Heat the sensor tip in a torch flame. The voltage should exceed 0.9 volts in less than 1 minute. Remove the sensor tip from the flame. The meter reading should reach 0.1 volts or below within 3 seconds. Now let's review the test procedure for an oxygen sensor that's still installed on the vehicle. Connect the voltmeter leads to the oxygen sensor lead and a good ground. Locate a manifold vacuum port or source. Start and run the engine until the meter readings start to vary or toggle. Create a vacuum leak at the port or source located earlier. Observe the meter reading. The voltage reading should fall below 0.1 volts with a vacuum leak and rise above 0.5 volts when the vacuum leak is plugged.
The tools you will need to replace your oxygen sensor include a 3/8 drive socket set, a special oxygen sensor socket, and a torque wrench. In some cases, you may also need a soldering gun and solder, a wire crimping tool, and some heat shrinkable tubing and a cigarette lighter or source of heat. And in all instances, you'll need the correct new oxygen sensor for your vehicle.
The first step in replacing your oxygen sensor is to start with a cool engine. Then locate the sensor and clip off the existing wire or wires near the sensor itself. With a socket of the correct size, remove the old sensor from the exhaust manifold. For ease of removal, you may want to use a special oxygen sensor removal socket as shown. Place a small dab of non-volatile anti-seize compound on the threads of the new oxygen sensor. Install the new sensor in the threads, starting it by hand, and tighten to recommended specifications. Install a piece of heat shrink tubing over the wires, and reconnect the wires to the new sensor with the crimper and butt type wire connector. We suggest soldering this connection with rosin core solder for a positive corrosion-free connection. For wiring details on your particular vehicle, consult the complete wiring instructions included with your new NAMCCO oxygen sensor. Then slide the heat shrink tubing over the connection and collapse the tubing with the heat gun or lighter until it shrinks and weather seals the connection. That's all there is to replacing the oxygen sensor in your computer-equipped vehicle.
Now let's review the steps involved in replacing an oxygen sensor. First, cut the wire lead for the oxygen sensor. Then, remove the sensor from the exhaust manifold or pipe. Next, apply an anti-seize compound to the threads of the new sensor. Install the new sensor and torque to specifications. Lastly, reconnect the electrical lead by soldering and using a heat shrink insulator.
Okay, now if you've got a vehicle that's running too rich, you might have some black smoke out of the tailpipe, and on this vehicle it's getting pretty poor mileage, Jim. When I went in and pulled the trouble codes out of the computer, I got a code 15. When I went to my trouble code chart, it simply says right here, code 15, open coolant sensor circuit. Now you've got a quick test of that coolant temp sensor, don't you?
Sure do. It's another one of the 2-minute tests that you can perform at home to find out if your coolant temperature sensor is working.
Okay.
Now here's one just like the one that's in this vehicle here. And, of course, it's out of the vehicle. It's not warm. It's cool. Inside of a coolant temperature sensor is a thermistor, which is a device that changes its resistance with temperature.
Sure.
Now, in this particular case, as I said, it's cool, so